Hi, everyone. I hope you're all doing well. And Happy New Year to all of you. This is the first stream of the year, and I'm really happy to be doing this. This has been a thought that I've had for a while now, so I thought we'll explore this. Now, this is going to be a slightly longish stream where I'm going to be making a lot of mistakes. I'm going to tell you up front. This stream came about because I wanted to orchestrate. I do a lot of vulnerability scanning. My team does a lot of vulnerability scanning. So we wanted to do that in a distributed way. We don't want our client machines or laptops getting utilized for that. We might as well let the scanning be done on a different orchestrated system. So we decided to go with a system where, or we want to go with a system where we are going to be able to just hand off that piece to some distributed system like Kubernetes. In this case, we're going to be using Kubernetes, and we are going to essentially run our vulnerability scans on that. So I'm going to be building a solution today. Actually, I'm going to be building a solution from scratch. So if you're interested in that kind of thing, this is going to be a lot of fun. So I'm actually going to be building a solution where I have this API that I'm building, and you can access this particular API, and then through this API you can trigger scans and start to scan whatever you want. You can schedule your vulnerability scans. You can start running your vulnerability scans on a distributed system, which is going to be Kubernetes. So I already have a Kubernetes cluster set up on the cloud. I'm using DigitalOcean. I just have like a very basic cluster set up on the cloud. So what I'm going to be doing is essentially this. So I'm going to explain the concept. I'm going to draw this out, and I'm going to actually go ahead and implement this as we speak. Right. So I'm actually going to go ahead and implement this system as we speak. So I'm going to build out an orchestrated vulnerability scanner on Kubernetes. I'm going to be using. So I'm going to talk about my reasoning for this and how I'm going to do it and why I'm using whatever I'm using. So that's basically going to be it. So let me just open up the stuff I need. Just give me a minute while I do that. So basically, I'm going to first draw out my logic and stuff. That's going to be the first thing I'm going to do. I'm going to draw out the logic and see how that works. And then I'm going to use Miro to draw out the logic part of this. So this is going to be how I'm going to do it. So I'm just going to open up, start sharing my screen. And yeah, so that's going to be entire screen. Yeah, so this is going to be me. So let me talk about the solution that I have in mind. So this is, let's look at this Kubernetes orchestrator. Let's call this. I'm just using Mira just to diagram it out. So for my own understanding and stuff, it's just going to be easier. So I'm just going to say um, idea, just going to call it idea, right? So basically, this is going to be it, right? So we have, just going to write a basic flowchart. I shouldn't have done this, but anyway, it's fine. So I'm going to essentially start off with some shapes. So this is going to be user. So I'm just going to, let's take a user group. So these are going to be my operators. So this basically right now is me. So what I'm going to do is these are operators who want to start scheduling vulnerability scans that they want to do on a distributed system. The idea here is that the distributed system takes care of that scanning process entirely, right? So there's nothing else that needs to be done. The distributed system takes care of that scanning process. So that's basically what these people are doing. Okay, so these are the operators who are going to be using the system, the people who are going to be using the system, right? So I don't know if it has a. Oh, it does. Okay. Oh, it has a Kubernetes. That's pretty cool. Okay, that's nice. So what I'm going to be doing is I'm going to be running my orchestration system. So that's going to be an application. So let's just look at what is a decent logo for an application. Yeah, let's just use this. Okay, so let's just use app orchestration API. Now, the orchestration API can sit inside or outside Kubernetes. It doesn't really matter at this point in time. Today, I'm not going to be writing it from inside Kubernetes. It's not going to be running outside of Kubernetes. But the idea here is over time, you can probably use ingress and stuff like that to run it. So the idea here is that These people will orchestrate it through a CLI or something like that. They'll talk to an orchestration API, and that orchestration API will schedule jobs or will create jobs on Kubernetes. And Kubernetes is going to launch a bunch of pods. It's going to launch a pod which is going to run the actual scan, right? So this is going to launch a pod that is going to run the actual scan against the server. So it's going to run the scan against my target target machine, right? So let's just call this target server here, and this is going to run. So this could be an app, it could be a whatever, it could be anything, right? So this is the structure that we're going to have. So this pod is going to be launched as a job, right? So I don't know why there's so many tooltips coming in here. I don't need it. I don't need this either. So this is going to be a job. So this is basically a job spec, and that's how it's going to work. So we have your operators. They're going to be talking to this orchestration API. The orchestration API is then going to be talking to Kubernetes, and then Kubernetes is going to launch the job, run the pod, and then it's going to run this against. And this pod, essentially what it's going to do from this point is to write back the results to this orchestration API. So this orchestration API is going to have a database somewhere. um, let's look at a slightly better database icon. Okay, maybe just call this whatever. I mean, it's not the right icon, but anyway, database, whatever we call it. Uh, so this is going to write stuff into this database, and we're going to maintain a history of the scans that we've done. So basically, that's what we are going to build. So today we're going to be building the actual scanning a job part of it. I'm not going to be talking about the user authentication system and stuff like that. uh, Today it's largely going to be this, right? So that is what I'm going to be building today, right? So not sure if there are any comments yet, but that's fine. Anyway, so this is, I probably am not going to be able to look at the comments too much today. I think because I have only one screen at today's setup, so I'm not going to be able to look at too many of the comments. But nevertheless, if you do have comments, you can reach out later or post it on YouTube or wherever you're watching from later on, and I'll try and answer it. Anyway, so this is what I'm going to be doing today. This is going to be my focus for today, right? So we're going to obviously build only the features that is essentially going to allow us to schedule this pod, run this pod, blah 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 blah, do run the job, run it against the target server, then write the results back into the database. So I'm essentially going to have to construct the job, construct the container, construct the API that's able to consume this, all of that stuff. I'm going to have to build out that entire piece that allows me to construct this capability. I'm not, again, like I said, I'm not going to look at the other things like user management and stuff like that. Okay. So now the components that I'm going to be using are essentially these, right? So let's look at the components that I'm using. So let's talk about the components. So this, of course, I'm going to be using the orchestrator API is going to be a Python fast API. Fast API, I'm just used to fast API nowadays. It's kind of nice. It's easy to work with. It's kind of easy to write code. It's also it automatically generates an open API spec. So it's kind of nice. It's very easy to work with. So I'm going to be using fast API. The database, we are going to be using a database called ArangoDB. Now, ArangoDB is essentially a graph database. It works. You can get it to work as a document store as well as a graph database. So on my machine, we have ArangoDB running on port 8529, and so I have this running on port 8529, and this is the system that I have. I actually have some of my collections are already in here. I have the scan, I have the user. In fact, I don't think I've created anything yet, but these are all the database tables that I have. I also am able to create graph relationships using the Edge database table here. So you can essentially, this allows me to map those graph relationships. I have not used ArangoDB too much. I have some basic exposure to ArangoDB, but I really like it because, especially of the graphing capability, it's really pretty cool. So I like it a lot because of that. Just seeing if there are. I just keep looking back to check if there are any comments. I'm just going to go back here, so don't mind the screen being the way it is. All right. Uh, so this is basically what I have. This is the setup. So we have ArangoDB, which is going to be the database, and we are going to, of course, be using the orchestrator distributed system, which is going to be Kubernetes, and I'm going to be using Kubernetes API, Python API. So Kubernetes has a pretty decent Python API. Again, I have not used it too much. I just done some basic stuff with it, very, very basic hello world level stuff with it. But today we're going to kind of explore it a little bit more. And they have some pretty useful, nifty examples. So I'm hoping to do that. I'm also going to be using, today, I'm just going to be building it on Nmap maybe, and maybe another tool. But the tools, you can literally build out container images or for whatever tools you want. So it's going to be container images for Nmap today. So this is going to be the orchestrated container image for that. And that's basically what I am going to do. All right. So let's look at the first piece, which is going to be building out the pod itself, right? So this let's start looking at this particular component and seeing how this is going to be dealt with. I'm going to let's talk about how the orchestrator API is going to work. So let's take this particular thing, and so the orchestrator API. So if you look at it, the way it's going to work is that the orchestrator API, the user is going to make a user is going to make a request saying, "Hey, I want to do an Nmap scan to the orchestrator API," and the orchestrator API is going to trigger a job, right? So this job, basically, what it needs to do, the job, each job that it needs to do is basically run the scan, run the scan tool with the specific arguments, right? Then it needs to once the job is done or the scan is done, it needs to write the scan it needs to write the scan results back to the um, API, right? So our orchestrator API stores scan results in DB. So that's basically what's going to happen here. So let's fill in the blanks here a little bit. So run the scan tool now. So this is going to be a dark, it's going to be a container that it's going to run. So this is going to be a container image, custom built container image, which has the ability to do, first of all, the scan with the scan tool, uh, write results into a result file. This could be txt, JSON, CSV, whatever, right? And then, of course, push scan the results into API. A little securely. Obviously, we want it to be a little secure. So let's talk about how that is done. So this part of it is what the job needs to do. And once this is done, it needs to terminate that job, right? Terminate the job. Now, the job spec API is something that we're going to be looking at as well. It's kind of new to me, so I'm also going to be kind of struggling with it. But ideally, the job spec API is something that we're going to be looking at as well today. Now, I have done some basic stuff. So this is the Kubernetes code that I've written so far, which is basically just connecting to the cluster. Basically, if you look at this code, it just allows me to connect to the cluster. So this is going to be cube. It allows me to connect to the cluster. It tells me that, hey, your cluster has all of these pods running as part of it. So this is me connecting to that cluster. The cluster is on DigitalOcean at the moment. But yeah, this is any Kubernetes cluster, right? So it doesn't have to be a DigitalOcean cluster or anything like that. It can be any Kubernetes cluster, right? So that is basically how this is going to be done. So we have our cluster. The cluster is up and running. We also have built out some basic stuff with the API, but I'm not going to focus on this at all. I don't want to focus on the user creation, all of that stuff. So today I just have this. I just want to make sure that I can get most of this done at least, right? So be able to trigger the job and then scan, write results, and of course have the objects that allow you to push on that. So we want the scans to be captured here, and we want the scan information to be captured in the database. That's really it today. It's just going to be this database table. I'm not going to be looking at how the this thing interacts with the projects and evidences and all of that stuff. Today, it's just going to be pushing scan results into the scans table and maybe the result information into the evidence table. So that's basically it. I'm not looking to do anything more as part of this session that I'm sitting to get this work done. All right. So I have this. So I'm going to essentially walk through my solution. And I'm going to also start committing my whatever Docker containers I have to Docker Hub and then start using that in our actual solution, right? So in our actual solution. So let's look at the first thing. So first things first, I've written a Docker container for Nmap. All right. So basically, what this is going to do is install Nmap on an Alpine container. I've kept it running with root. Again, although you should not run containers as root, remember I'm running security tools. I need typically most of the time, especially Nmap, I know for a fact needs root privileges on pretty much a lot of the scans that you want to run. Right. So that's basically how it works. So I've written this Docker container with the nmap specification, and this is going to run a script that I've written called the init script.sh. So that's basically what this is. Now, if you look at the init script.sh, this is pretty straightforward. So let's look at what this init script.sh is doing. So what this is doing is that it runs nmap with whatever scan flags I pass in the job as part of the job. So the job is going to pass a bunch of environment variables, right? It's going to pass the scan flags, the target, the listener URI. It's going to pass the authorization token. It's also going to pass, and once the nmap scan is written, it's going to. So basically, I'm passing in a bunch of environment variables. It's going to be the scan flags, the target, and the listener and the token. This is something I'm going to pass with every job. So the listener is my API, the orchestration API. So this is going to be the listener. And the scan flags are also going to be something that I'm going to be passing with every job. The target is also going to be something that I'm going to be passing with every job. And the token. Now, the token is interesting because we are going to have a token that is generated for every single scan. So as soon as we create a scan, so we're going to have a token generated. That's going to be a secret token. And then we are going to launch that, right? So that's basically how we are going to be doing things. So just making sure that there are no comments yet. Okay, that's fine. Looks like there are no comments yet. I'm just making sure. I'm just going to check back to the screen now and then, make sure that there are no comments. All right. So what this is going to do is once the nmap scan is done, nmap we are going to write it to a txt file. We're not doing anything fancy, no XML and all that. Of course, if you want to parse it, we can do an XML. But for today's session, I'm just happy with writing a results.txt file. And this results.txt file, if it's written, which means the job is done, it's going to essentially write that results.txt file to that slash root. And then we're going to base 64 those txt results. And then we're going to push it into our API as like a webhook, right? So our API is equivalent to the webhook, and we're going to push it into that. So that's what we are going to be doing. So uh, that's our approach today. So let's actually go ahead and start implementing this. So the first thing that I want to do is I'm just going to keep this because this is useful to have either way. So I'm going to do app.put create. So I'm going to create a scan. So once I do create scan, this is an API call that I have. It is going to create a scan for me. It's going to create a scan. It's going to create some variables related to the scan. And then once it's done, it's going to push it in there. It's going to essentially, it's going to create the scan, and then it's going to launch that scan on Kubernetes. Kubernetes is going to orchestrate it. It's going to load the pod. It's going to run the nmap scan. It could be nmap. It could be AMAS. It could be any of the tools that you want, right? Any tool that you want to use from an automated standpoint. That's what we're going to do. And we're going to create the scan. So it's going to create scan, and we are going to use a particular serialized data set for this, right? So let me remove some of the unnecessary. Yeah, so I'm gonna create my, yeah, so I'll create a Pydantic class, which is basically going to be the data structure that I'm hoping to receive from the user, right? So this is going to be create scan. This is going to use a base model, or shall I just use the standard base model? Create user. Yeah, no, I think the standard base model is just fine. So it has, so base model essentially allows you to set the created time and all that stuff. It's automatically done. So this is going to be the tool. I need the tool name, obviously, which is going to be a string. I'm going to set this to mandatory value. Flags, which is also going to be a string, which I'm going to set to a mandatory value. And I that's really it. So I'm going to generate these two values. And after this, I'm going to generate another value, which is going to be the scan name value. So this is going to be things that I'm going to do elsewhere. So this is going to be, I'm going to generate inside the function which I'm implementing, which is going to be the scan name value and the scan secret value. So the scan name value is going to be basically the scan that it's associated with, and the scan secret is going to be the scan. It's going to be the token, right? So every time we use a token, that token is just one time used for that particular scan. So after that, the token expires. So we're going to be having two things that we are not allowing the user to set. So this is basically the data structure that we have. Just give me a second. And yeah, again, just checking back to see if there's anyone. All right. So this is basically what we have. So this is our create scan object. And again, I'm going to be implementing this. So this is going to be scan, and I'm going to call it create scan. So I'm going to use this as our serialized data structure to be able to consume this, right? So right now I'm not implemented authentication, authorization, all that. Yes, it's important. I know that it's important, but today I'm just implementing this. And once I have my user management completely done, then I'm going to implement it separately. Maybe I can do another session. Maybe I can do another stream on that. Right now, my only interest is to make sure that we have the actual thing, the the scanning piece working for the most part, right? That's basically what I want to do. So now we want to insert this into our database as well. Remember, I want to insert this into our database. I'm just looking at the previous quarter. I've had intermittent experience with ArangoDB, so sometimes I'm not super familiar with the calls that are being made here. So in this case, it's pretty simple. They have a few things that we are doing here. So you just need to insert a dictionary value. That's fine. So we have Arango, which needs a scan. So that's basically what I'm going to do. All right. So we're going to use the Python secrets model. So I'm going to import from UUID. I'm going to import UUID 4. And from secrets, I'm going to import token URL safe. So I just want to generate, for my secret, I want to generate a URL safe token, which is what these are two functions I am using, right? So I'm going to create my scan, and then I'm going to use the Kubernetes object to actually push that into it. So I'm going to look at the Kubernetes object. I'm going to have to do that. I'm not used this job specification before, so I'm really not sure what to do in terms of setting up the job. I had done this in a with the YAML, but with through the API. Obviously, I don't have the luxury of the YAML. I'll have to build it in code in Python itself. So I'm going to be building the Kubernetes job spec in Python. So that's basically what I'm going to be doing. So Kubernetes jobs are a different object. So if you look at Kubernetes jobs, you will see that it's basically it's the as the name suggests, it's a pod that runs a task and then deletes, right? Successfully terminate. That's basically what it does. So this is what a job looks like. It's just essentially a job that runs some command or some whatever piece of code, and that once it's done, right? It has in this case, it has a restart policy. Of never You can run cron jobs as well. So you can use Kubernetes as a pretty powerful system, because not only can you run persistent applications like web apps or databases and all of that stuff, you can run jobs. So I want to use, as much as possible, I want to use the native Kubernetes functionality, and I don't want to have too many dependencies that I'm using. So this is native Kubernetes functionality. So this is, since it's native Kubernetes functionality, I want to use the job. Right now, ideally, I would want to do this using a service account, but today I'm not focusing on the user account stuff. Ideally, what I would want to do is create an RBAC policy in Kubernetes where I create a service account and I say that this service account is only limited to launching jobs. That would be the best way to do it. But today, since I'm just testing things out, I'm writing code. Think of it as a local development environment. That's basically what I'm doing. I've even set up a very basic single node cluster that's not it's not connected to anything, but ideally that's what you should be doing. So this is how you would run this, right? So you would have a whole bunch of things that you can do. You can run cron jobs, you can run standard jobs. I'm going to be running a standard job because I don't need it to start every single time. It's basically on demand. So once the user launches the scan, that's when the job launches. So that's basically what we need to focus on, right? So this is what we have, and I think there is some useful code uh, with the Python API as to how you can run jobs. This is really useful because this will help me understand how to actually do it. So, create the job object. This is what we want. So, I'm going to be using this. I'm going to pretty much be uh, mooching off of this to be able to run my job, right? So, that's basically what I am doing here. All right. So, all right, so this is the job object. I'm going to be running Kubernetes job, and yeah, that's basically it. So now let's actually run my code. Actually, start implementing this. I'm going to remove all of this stuff. This is not necessary. I just made sure that it was working and it was actually connected. So I'm going to create scan job function. I'm going to pass it a bunch of variables, which is going to be the listener host, which is going to be, then we're going to pass in the listener host is a string. We are going to pass in the secret, which is also a string. And we are also going to pass in. So, what do we need for this to work? We need the target, we need the flags, we need the listener host, and we need the secret. Right? So, we need these for this scan flags, target, listener. Cool. So, target, which is again a string, and we need the I'm sorry. Listener scan flags. We need the flags, which is also basically string. So that's all we need. We need all these four things to be able to actually implement this scan job, right? So that's basically what we're doing. Now I'm going to push this container into my Docker hub. Uh, so this is going to be Docker tag nmap. Hopefully, I have everything in place. I might have to push it a little bit later, but nevertheless, Docker tag nmap cube as v45 map Docker push v45 nmap cube. Yeah, it's just a basic nmap container that runs an nmap scanner. You can follow the same approach for everything. I'm planning to follow the same approach. Run the tool, get the results, check if the results are actually written. If the results are actually written, then base 64 or do whatever else you. It would typically be a base 64. I would imagine that I would have to base 64 the results, because many of those results might not be in formats that I can just push over the wire. But if they are JSON, then maybe I can do that. Maybe later on, if I'm really interested, I can probably even use S3 and push it into an S3 and generate some kind of a pre-signed S3 URL. Maybe that would be easier, and just write the key back or write the API. But in this case, I'm just going to do it because I know that Nmap is this way. But ideally, I would say that probably the more optimized solution would be taking this, pushing it into S3 using a pre-signed URL so that it pushes it one time, and once it's done, it doesn't have access to it. So it's kind of nice to be done that way, because you don't have to have this written back to the API. But in this way, the API gets a notification that it's done. So that's basically why I am doing it this way. This is just my preference, doesn't mean it's the best way out there. So yeah, so this is basically what I am doing here. So I've pushed this to my Docker Hub. So if you go to hub.docker.com/u/ yeah, nmap cube. Looks like we have it written in. So we just have our nmap cube container image. Alrighty. So we have this. We have our container image set up. Now we have to implement this, right? So we are going to scan db, which is going to be db.collection. We're going to write it into the scan table, which is in our Arango DB. So this is going to be scan. And what we're going to do is we're expecting two parameters to come in from the user side, right? So we have the scan info, which is going to be the scan.dict. We're going to add two parameters more, which is going to be the secret. So scan secret, scan info of secret is equal to token. So I'm going to generate a random secret value, right? So just making sure that I don't know whether it writes to byte array or not. I'm not 100% sure. Let's see whether it actually does that. Hold on. So from secret import token with Python 3 and Python 2, especially once the uh, secrets. Oh, sometimes you end up having problems with token URL safe with byte arrays and strings. So it generates it as a string. Probably a larger token value. It seems small to me. So maybe double this and make it 32. Yeah, this seems okay. Uh, token URL safe. So it is URL safe. So it should be fine. I'm not sure. Okay, so let's keep it token URL safe 32 and then scan info. Actually, let's make this a separate variable. Secret is equal to, and then we can use this as the secret here. Now we also need a UUID. So from again UUID also I think is byte array. It's kind of weird. Python has string of UUID for. So that's the scan name. That's going to be the auto-generated scan name that we are going to give it. So if you see our models, you will see that the scan name is going to be autogen, and the string of UUID. So basically, that's what we're going to do. So it's going to be name, and we're going to do scan. Okay. And now we're going to, so basically at this point, we can insert it into the database and then run the job, right? So after this is when we want to run the job on Kubernetes. So I don't think I have the ability to, or I don't have the time to look at the specific exceptions. So I'm just going to draw a generic exception and then focus in on the specifics later on. But ideally, that's what I want to do. Scan db dot insert scan info. So this is going to be me inserting it into the database. So this is only half done. Obviously, we've still not finished most of it yet, right? So logger.info scan. Just going to write this to an API log. I think I've been maintaining an API log. I'm not sure. I think it just writes it to standard out right now. But yeah, you can. I'm using a logger system, so you should be able to. That's going to be scan underscore name created database. So just go, yeah. So here we have our um, scan logged to the database. But now it's important for us to be able to push this into the Kubernetes job, right? So that's what we're going to be focusing in on right now. So we're going to push this into our Kubernetes cluster as a job, and that's what we want to be able to do, right? So I'm going to close all this stuff. I don't think I need it. I'm going to call this components. Let's just call this components.empty. Just I'm going to remove this as well. Now, we have our, sorry about that, I'm not sure. Yeah, so we have our models where we have the tool and the flags, right? And we need one more thing here. We need the target. Forgot about this. This is important. And we don't need the listener at this point in time. I'm going to essentially I'm going to hard code the listener for at this point in time, but ideally the listener you have to implement it a little bit more comprehensively. But target, yes, absolutely required. So the tool, the target, uh, the flags, right? So this is nmap. So right now the tool I'm only implementing one, so it's kind of going to be hard coded, but or when I pass it, I'm going to just pass it as nmap as the default tool. So let's just call this tool nmap for now, so that it's just basically set to nmap, right? So we have nmap, the tool, the flags that we need, the target that we are scanning. And that's all of what we need, along with the other stuff, which is the name and the secret. And this is going to be what, so the flags, the target, the listener, the token. So all of this is set. The listener is something I'm going to hard code for the time being, because I don't want to, sit and set up I'll have to figure out based on the URL and where it's launched and things like that, and have some kind of environment variable for it. Since I'm doing it locally and it's going to have to connect to me over ngrok or something like that, I'm not going to do that right now. So it doesn't really matter. Just checking, just checking back to see if there are any questions as always. But yeah, anyway, that should be fine. Now let's go ahead and implement uh, the actual scan, right? So let's implement the job. So this is going to be, so basically, I think container spec, the template spec, okay, restart policy never. We need something else as well. So one of the things that we are going to need is we need, in fact, I searched for this. I myself had done this at some point in time. It's on one of my tweets. So I need to search for it. Sometimes it's always useful to tweet because uh job Kubernetes. Yeah, this is the one. So this is what I want. Uh, I want the image pull policy to be set to always, because I want to pull the latest image all the time. I want the restart policy to be set to never. And I want the TTL seconds after finished to be 10. So after it's done, it's going to delete, right? Hopefully this works. So I'm just going to keep this open because this is useful to me, and then get back to it, right? So this is what I want. I want to be able to run the job in this case and back off limit. Now that's interesting. What is back off limit? I think it's the yeah, I think it's the number of times it will retry if the job is not working. And that's the back off limit. You also have parallelisms and stuff that you can do. Yeah, so restart policy, this is pretty straightforward. Yeah, if you want to fail a job after some number of retries, yeah, exactly, back off limit. So it looks like once X number of retries and then the job fails. TTL, yeah, this is what I was interested in. I'm not sure whether this is applicable now, because at that time I was looking at a way to run another init container to be able to push the results, but now I'm not doing it. I'm doing it entirely within the container itself. So it should not be a problem. So I don't need this. I don't need TTL seconds after finish. So clean up after finish jobs is cleans the job, it will delete the job cascadingly, delete all the dependent on. It's still a good thing to do from the looks of it. It's good to have to complete the to delete the job and all the necessary resources related to the job, right? So I would definitely do that. um, what I'm going to do is I'm going to set up an ngrok. So I'm going to be running my app on 8000, so this is going to be, so yeah, anyway, so this is going to be this, and this is also there. Okay, this is fine. Okay. So since I'm going to be writing it locally, I'm just going to have to get the listener to connect back to me. So now that we have this, I'm going to remove the try for the time being and just work without it and then add it in later on. Ideally, I should be doing it at the same time, but that's okay. Now let's look at our job CRUD. So I'm just going to copy this because it's just easier to copy this and then work through it, especially since we're doing it right now. So, okay, I already have, okay, I don't need this here. I need this elsewhere. My bad. So they have a nice CRUD example right here. So kind of useful. All right. So this is going to be client.view on a container. So this is going to be nmap cube. And it's going to be 45 nmap cube. I don't need any command because it's already pre-configured, but I do need environment variables. I do need environment variables. So, what's the format for environment variables? That's interesting. I need to figure that out. So, labels, it's going to be app, it's going to be restart policy never, containers, whatever is in the container here. The spec should also, like I mentioned, needs to have the TTL after seconds finished. So, is that something that is implemented here? Uh, okay. Doesn't seem to have anything here. Pod spec doesn't seem to have TTL implemented. So I'm just going to leave that out, I guess. Or is it the wrong object that I'm looking at? Pod one object meta. No, it's in the pod spec. It's in the pod spec. I guess they're not implemented it in the Python uh, restart policies in there, service account. Of course, I should be doing this with a service account, like I said in just before this. Service account is important, but since I'm not implementing anything yet, I'm not implemented user management yet, so I'm not gonna do that right now. Doesn't seem to have the TTL thing, so I'm gonna leave that out. It doesn't really matter from the looks of it. Template here, back off limit. Oh, is this the job spec? I think it's in part of the job spec. Yeah, okay, here we go. TTL seconds after finish. It's not part of the pod spec, it's part of the job spec. Okay. So we have, let's set it to 4. Back off limit is 4. The template is set. This is going to be nmap cube. Just call it nmap cube everywhere. I don't need the commands, but I do need environment variables. So Kubernetes, does it have the ability somewhere to set environment variables? One, I'm not sure whether the Python CRUD thing has envars anywhere. Pod exec, args, it has args. Pod envar, yeah. That's what I want. Yes. So I want it in. Oh, it's part of the env. Okay. So this would be inside the container. Okay. So the container spec should have, okay, looks like, okay, we have environment variable, which is also another object, v1 envar. So I need to load 3 or 4 different envars. So let's initialize those. So the first environment variable is going to be listener, and that is going to be client.v1 envar of type. Name is going to be listener, and value, I think the name has to be a string, and value is going to be whatever this is, slash scan. I'm just going to keep this pretty straightforward. Then I have another one, which is going to be my flags. So this is not required because I'm passing the string in there. So this is going to be listener host. Perfect. The value here is going to be flags. Then I have 2 more, which is going to be the secret, which is going to be my secret that I'm passing in here. And the other one is going to be the target, which is going to be the. So this is basically a list of just individual environment variables that have been declared. I think this is a problem because I need to give them the same names. Problem. Okay, so let's instead of command is going to be a list of listener flags. I'm not sure whether this is the right way to do it, but hey, target. So I'm initializing them as environment variables, and I'm going to change them. Going to be scan flags. Going to be seek token. Sorry, called a token in my spec. This is going to be the target, of course, which is pretty straightforward. Yeah. So now we have our job. I'm not sure whether this job is going to work, but nevertheless, what is the job name? Okay, is there a job name? Oh, what's this? This seems fine. So our environment variables seem to be working, or at least they've been loaded. I'm not sure whether they're actually doing something. TTL seconds job. Where is the job name here? Is that something that was there before? You can essentially load a string, right? Just call it nmap scan job, whatever. Nmap cube. Let's just give it the same metadata name just to make sure that it's actually all right. So this seems to be set at least. Now the point is whether our we're going to import this from cube import create scan job. This is where I have to create scan job. Is going to have to call listener host is going to be something that I'm going to hard code. Just give me a second. It's this. This is going to be up and running. And then we have what else? We have so host secret is going to be our secret. Then we have target, which is going to be, I'm just going to give a target, which is going to be demo dot. Actually, this is already passed, right? Scan info dot get target. It already has it as part of the model. It should have the target as well. Yes. And just going to line separate all of this. And target is going to be okay. And the last one is going to be flags. Okay, so I'm going to hard code the flag. Actually, you don't need to. This is going to be scan info dot get flags. Is that flags? Yeah, yeah. All right. So this is what we are doing. So basically, right now, since we are hard coding a few things, that's fine. I'm just using Nmap, but uh, right now I'm just essentially hard coding it to Nmap. But later on, based on the tool, so based on whatever is the tool here, I should be able to change out my tool, right? That's basically what I would want to do when I'm doing this in the real world. So hopefully this works. Okay, so we have this for the timing. Let's see whether this works. Now I'm going to start my server and it's going to load the, and I'm going to make an API request to create scan. So that is going to be, actually, I forgot to do this one important thing. I've actually forgotten to provide any return values. Return. So I'm just going to scan with, okay. So that's basically me running this scan. Hopefully, let's see. So I'm going to make a call. So I'm going to make a post request to localhost 8000. It's going to be create scan. And now I'm going to have to. So tool is going to be in map. Target is going to be demo.testfire.net. This is an intentionally vulnerable application that's on the cloud that is used for web application, learning web application security and stuff like that. So it is, I'm not firing at a real world target. This is just basically for practice and testing. So that's why I'm using it. And of course, flags is going to be, I'm just going to do some basic and map flags for the time being. Okay. What method? No, oh, it's a put. Okay. Okay. Created in DB, but I am not sure whether it is actually. Oh, is it namespaced? Hmm, not sure whether there is a namespace that I'm missing somewhere. Okay. I am not sure whether it actually ran. This is interesting. Running pods across all namespaces. It's definitely written to the database. That's no big deal. Nobody cares about that. That's still kind of basic right now. Doesn't really matter. But didn't seem to have done anything in terms of writing a job. I don't think so. All right. Um, let's create a job spec and actually see whether it's working. Let's create an actual job spec because for some reason didn't nothing got created. I'm not sure whether there's a bug in that container or not. That's something I need to check, but maybe there is. Let's see. So here, just gonna do this. I'm just gonna copy this and gonna need to figure out a more graceful way of job.yaml of figuring out of writing this stuff, but that's fine. That's okay. And map cube. Seconds after finish, let's keep it to 10 seconds maybe. Uh, and map cube. Okay, I don't need commands, restart policy never, but I need environment variables. And those are, yeah, like so. Just gonna copy this, just make it easy for the whole thing to work. Same level as the image. I need to have a linter for this is fine. So I have scan flags. It is scan flags, right? Yes. Okay, so this is going to be P N S B to S S. Then we have listener. Oh, only double quotes here. We have our listener here. I'm just going to copy this stuff over here. Then we have a target. Going to be. Did my listener hit anything? No, nothing. Okay. Target demo.trustfire.net and secret. Although we have not implemented any secret validation at this point. I'm just going to give it a 1, 2, 3, 4. Doesn't really matter because I'm not validating the whether it's the right secret. I'm going to do that later, but I just want to check this first. Target listener token. Okay, that's token, not secret. Okay, so this would be something I can check. kubectl. This is going to be kubectl apply -f. Okay. Get parts, all namespaces. Okay, it seems to be running. Okay, nmap cube seems to be running. Oh, it's done. Completed. I think it would have tried to write to my listener, but it would have failed. Yeah, bad gateway. Actually, let's turn this on and see. So it's working. It seems to be working. It seems to be working just fine. Yeah, so in map that the TTL seconds after thing is also working, so it's all good. Now we need to check whether this works again. So this is of course map cube working. It should run the scan, and once it runs the scan, it should contact my listener to get the result, right? So basically it should I should have the result pushed back to this. Yeah, it's completed, which means that, yeah, looks like it's pushed to this. Did I print it? Oh man, don't tell me I didn't print it. I just printed the auth header. Oh man. Print request dot. So let's just print the whole thing. Rerun the job. Oh my bad. So it's terminated. Looks like it's just doing a basic scan. Yeah. So it's creating the container, it's running, and it should do the job, and it should write the base64 encoded scan result right here. Just wait. Yeah. Oh, sorry about that. This is the problem. I'm not used to async code in Python. Uh, is this the right way to do it? I'm not sure. Wait, print. I think that would be the right way to do it. Yeah. Can't imagine that. So this is all right. So if this works, I need to figure out that we just need to troubleshoot and see why the spec was not created. What? None type. Okay. Uh, this is strange. I'm not sure what I am doing wrong. Instantiate the job object. Okay. Oh, create the job object, create job. Oh, I have not run it. That's the problem. All right. Yeah. Okay. So this needs to be in the namespace. Okay. Yeah. Yeah, this was the mistake. So you are getting the job status, API instance. Yeah. You can actually do that. Yeah. So I created the job, but stupid that I am, I didn't actually launch the job, which is kind of dumb. But nevertheless, let me figure out first of all what's happening with this. Uh, I don't need to print it out because I do, and I'm just not able to figure out what I am doing wrong with this. I just need to make a small. Do I need an async def at all? Can I do it just def? Why can I just manage it like that? I don't even need the authorization header. I don't care about that, but nevertheless, let's see. Let's rerun this job again. I think I know what I did wrong now. So I think I'm kind of close to figuring this thing out. I think it should be okay. I should have put an image pull policy to always so that it pulls the fresh image all the time. Ideally, that should have been a thing I should do, but that's okay. So we have this. Yeah, that's the problem. This must have. Is it JSON? Async. It has to be an async diff. Yeah, that's the problem. I'm not used to this in Python yet, which is why I don't know whether this works either. Let me just check. Right? I get that, but just checking whether I need to make some change to this. Sorry about the background noise. There's a I'm sorry, I don't have the exact detail. I'm just going to dump the JSON. Um, See, I don't need to do that. I already have a model which has the results, and that's what it takes it anyway. So this is going to be results, result of type get result. So I'm just going to print result dot ticked. That's it. I don't need to worry about that. And I'm going to return result. That's it. Dot ticked again. That should be fine. Let's give it another shot. I think this should work now. Hopefully, it should pan out. So what I'm trying to do here, and that was yeah, it's working. It's working just fine. So it clearly means that so we're getting our results as well. So you'll see that if I base 64 this stuff, our nmap results are there. So it's working just fine. So the mistake I was doing, and I think that was validated very clearly, was that I was not launching my job. I was just like um, going after it. So I had just created the job, but I was not launching it, which was kind of daft. I'm gonna obviously do that, and then this is going to work. So it's working. My API is working. My listener is working. Most of it's working. I just need to make sure that I actually go ahead and launch that job. So this is going to have to return some kind of a value, right? So that is going to be something I'm gonna. So API instance. Okay. So what is the API instance here? The term API instance, create job. Okay. Oh, okay. It's just going to be the client, I guess. Oh, batch v1 API. Okay. Okay. So this is going to be client dot batch v1 API. So that's that. I'm just going to call this job client. Okay. So job client dot create namespace job. Okay, that's what I need. Just need a very simple create namespace job, and it needs to be this, right? Body or whatever the job is. Is it create namespace job, body and namespace? Okay. Body is equal to job. And I'm just going to launch it in namespace default. Now, this is again not a good thing to do. What you should ideally be doing is launching it into a very specific namespace, use a service account that's limited to that namespace, have a service account that's only got the ability to run the job, perhaps, right? So that would be the best way to do it. But I'm just checking things out here. So I'm just making sure that that's how it works. API response dot status. So I'm going to return that API response dot status. I'm just going to return that. That's good enough for me. So this would be the job ID, the job name, all of that jazz. And I think you can get a status, which I'm going to implement later on, but not going to care to implement it right now. So I'm going to essentially return the job client dot response status of the response. I'm sorry. Okay, just dot status. Okay. Okay, that is okay. Okay, sorry. Looks like this is the response. I'm just going to do response dot status. I think that's it. Yeah, because this is going to, yeah, this is basically an HTTP API call, it's going to get a status, and that status is going to be returned. All right, so I am going to status. So this is going to be this, and I'm just going to print out the status for the time being, but later on I can use that and maybe do something else with it. But right now I'm not going to bother with that. I'm going to remove I'm going to keep the dictionary print as well. That's good enough for the time being. So my API should be working now. Now let's see whether when I make a request. So if this works, it should create my job. So basically, if I make a call to this particular API, which is my Python API, it should talk to my Kubernetes cluster, launch the job, get the job launched, and give me a status. And I can, of course, keep polling the status as and when I want to. That is, of course, a secondary feature. I'm not built that yet. So I'm just going to launch the job and check whether it works. Okay. Strange. I think it takes some time for it to launch the job, perhaps. I hope it doesn't run timeout. Okay. This is strange. What happened? Very strange that my create scan is not coming back with anything. Something is not working as intended simply because I'm not sure why. It's strange. Is it because it's blocking? I'm not sure what's blocking. Is it creating the scan? I think it is. I don't see the problem there. Okay, there are two objects. create scan job, right? We are looking at an HTTP timeout for some reason for the looks of it. Let's see. Okay. And what mistake am I making? Okay. But I'm going to shut this terminal down and open up another one. Hello. Yeah, looks like it is working. kubectl get jobs. Oh yeah, it's working. So clearly, my job has launched successfully, even through my API. So I just need to study this and figure out what I need to consume as part of the status. So clearly, it means that the status is coming back with blah blah blah, a whole bunch of things. But and then it should, as always, write. Yeah, it's writing the results as well. So you can see that we have actually gone full circle. We've implemented a very basic orchestration right now, but it works. What we have essentially managed to do is kind of come full circle here. So if you look at it, uh, we have an orchestration API that's talking to Kubernetes, and I can, of course, the later on I'm planning to host this here. It's going to be on Kubernetes, but I can use Ingress or whatever. I can use do that. So this API is talking to Kubernetes, instantializing a job. This job is running Nmap against a target, and then the job is writing the results back to the orchestration API. So this would be much easier if the orchestration API was inside Kubernetes, because the job would be able to discover the pod, discover the orchestration API pod, and then orchestration API service, and then write the results back to that service. That would be the best way to do it. You can even have network policies in there to make sure that it works. But yeah, that's basically how it is designed to work. So this is working. The scan results, I can get the scan results to write back to the database. Now let's actually complete that circuit. So this is going to be just making sure. Now we need to do a little bit of validation. Just I'll need to implement a system where I can read the request header. And once I read the request header, I should be able to, push that in through. So right now, I'm just going to not bother with the header so much. I'll just push it as part of the job itself. So I can do it this way. I can push the token this way. Not sure how you do it with Fast API. I'm a little, but yeah, I can write the results to the scan. In fact, if I just pass the scan name as well, I can even do that. I can query by secret and do it that way as well. So that is also doable. So I can, right now it is, I have a secret, and if I just query by that secret, I can just use that secret, query by that auth code, and then take that and dump the results in there. That is something that I can do. I'll probably implement that later on. But yeah, this is how you can actually do this. So this I'm planning to do for a lot of other tools, AMAS, Nmap, uh, a lot of other tools that we use, right? A lot of OSINT tools, a lot of even basic things like fuzzers and some basic CLI based web app scanners and stuff like that. You can implement like this. So you don't have to run this on your workstation, or you don't have to run this parallel. You can parallelize a lot of this. You can use jobs. You can run them as part of a workflow. In fact, I think workflow, you could probably use something like Argo or something like that to be able to automate most of your workflow. So that's basically what I am thinking of doing in the future. But this is working. This is quite nice that I was able to implement this. We were able to implement this. At this, of course, it's still kind of very raw. There's a lot more that needs to be done. But yeah, this is a good start because we've been able to understand how you can configure a job through the Python API, start the job, get the status of the job. In fact, it even gives you the status, start time succeeded, active. Yeah, so it seems to have. I just need to study this, figure out which is the specific uh, key and value that I need to take for me to understand what is the status of the job. So the job name is there. Just trying to figure out what is the status. Well, this is the job. Okay, I think I just let's print the response. Just print the response. Yeah, this is okay. Let's print the response and see. Okay, so I think the response is also quite verbose. Yeah, this is basically just the dump of the object. So I imagine that it would be this. So this is just the OpenAPI spec. I just have to probably study the OpenAPI spec and see how this works. Yeah. So again, I got to do a lot of things. I need to implement the service account. I need to namespace it. I need to restrict it through RBAC. I need to be able to call that service account, use that service account. Failed none. Start time none. Succeeded none. Start time none. That's weird. Active none. I wonder how I'm actually going to be able to get status from here because I think I just have to check for failed none. That's weird. Uh, that probably be it. I'd have to query the job name, perhaps. Yeah, no, yeah, just query the job name. Yeah, I think that's what they've done here as well. I think I just have to query the job name, job status, job name. Yeah, that's what I have to do. I don't need to do anything much else. I don't. I think the status is kind of not super useful. Just get the job name, use that job name, and check whether it succeeded or failed or what have you. And I think you have ability to do that right here, so that's pretty useful. So I'll just probably end up doing that when I actually need to implement it. Anyway, so yeah, so today I had a blast. Actually, it was a lot of fun because I kind of discovered this on the fly. I hope it is not too frustrating for some of you watching me wade through my problems right now, especially through the API building process. So this is what I was hoping to do, and I've done that to a certain extent. I still need to do a lot more security stuff, especially validate the token, ensure that the scan is written to the right place, have evidences for that, write it back to our AngoDB, and make sure that all of this is working just fine. I also want to write a CLI on top of it to make sure that the interaction with the API part of it is a lot more straightforward, easy to work with. So that's what I am hoping to build out over the next probably a couple of months. From the looks of it, it's going to take some time, especially with the kind of workload I have. But yeah, this was fun, and I hope you had fun on the stream as well. If you do have any questions, oh yeah, oh Bharat, oh thank you Bharat for your shout out. Yeah, Axiom framework. Yeah, I know there are a couple of things that do this. I just want to build out something myself. I just like. I know it's maybe reinventing the wheel. I'm sure other people have done this, but I wanted to learn how to do this myself because it's just kind of fun. It's always fun to implement things yourself. But yeah, appreciate it. Yeah, so this was my first stream for the year. I hope all of you are having a great 2022. Stay safe. I know that Omicron's still out there. Please stay safe and all the best. And I'm coming back with another stream on 27th, which is going to be an SSRF workshop, which is actually going to be a live workshop. You're going to get to actually walk through some of the SSRF examples and labs and stuff like that. You are going to have to be part of our Discord community for that. So I'm just going to post the Discord chat link in here uh, for all of you to be a part of that community. That's going to be an exclusive members only stream. So that's not going to be like this. This is something we're streaming over YouTube and stuff like that, but that is going to be an exclusive members only stream. And you don't need to pay anything to become a member. You just need to be part of that Discord channel. So I am looking forward to seeing all of you there. It's going to be an awesome training. I have some very new and very awesome SSRF content that I've been working on that I want to showcase with all of you. So that's what we're going to be doing. Until then, have a good one. Have a great 2022, and I hope this is a productive year, a good year, prosperous year for all of you. Thank you very much. Bye bye.